Hello, everybody. Today, this is Mr. Delamorte. We're going to talk about factoring difference of squares. This is day 2. We're going to start with a little bit of review of some old material, and then we'll go into the new difference of square problems. Okay, so here is what you should know so far. If I just have a basic quadratic, okay, I am going to write this function. Excuse me here. Let's get this pen working. Okay. If I have a function, I'm going to break up a quadratic into a product of two smaller factors. So I do that. I'm going to break that 7x squared into just 7x and x. I like to list out all the possibilities for -4. So 1 and -4, -4 and 1, 2 and -2, -2 and +2. And one of those possibilities has to be the right one. But what I need to do is I need to check each one by one to figure out which one's going to give me this 12 in the middle. Okay. And the one that I want to try first is going to be this one at the end. So you're going to see me check it here on the bottom. I'm going to say 7x minus 2x plus 2. So I put the -2 and +2 into those parentheses. 7x times x is a 7x squared. I'm distributing. 7x times 2 is a 14x. -2 times x is a -2x. And -2 times 2 is a -4. If I combine like terms, I do get that 12 in the middle. So I do know my answer is going to be 7x minus 2x plus 2. Okay, and this would be my final factored form. Okay, I have a second one. So if I do the same thing, I'm going to make my parentheses. I'm going to separate that first term into 3x and x. I'm going to write out my possibilities for -12. I'm going to say 1 and -12, -12 and 1, 2 and -6, -6 and 2, 3 and -4, -4 and 3. Now I have a lot of possibilities here, so it might take me a few tries. I'm going to try a couple out, see what I get. I'm thinking I want to try this last one first. Okay, so if I check it out, I'm going to say 3x minus 4 and x plus 3. So if I distribute, 3x times x is a 3x squared. 3x times 3 is a 9x. -4 times x is a -4x. And -4 times 3 is a -12. If you combine those middle terms, I get a 5x squared. And that's actually what I wanted. So lucky me. I did pick the right one first. Okay, so this would be a 3x minus 4x plus 3. Okay, if you don't pick the right one first, just keep checking until you do get the right factors. All right. Now, some things that we have to watch out for. We have to watch out for when this is cubed. So if this is cubed up here, we need to start looking for a GCF. We need to start taking out a greatest common factor. So what I'm going to do, what I'm going to do is I am going to look for the largest term that can divide all of those individual pieces. So if I look at 6x cubed, -21x squared, 45x, what's the biggest number or term that can divide those things? Well, 6, 21, and 45 are all divisible by 3. And each one of these terms has an x. So if I divide a 3x out, now watch how I write my function. I always write the GCF out front. 6 divided by 3 is 2. This would be x squared. 21 divided by 3 is going to be 7. X squared divided by x, I'll just have 1 left. 45 divided by 3 is a 15. and I would just have those brackets. So now, if I do this, I can factor those brackets the same way that I factored everything else. So off to the side here, I'm going to write out my possibilities. And for negative 15, I have 1 and negative 15, negative 15 and 1. 3 and negative 5, negative 5 and 3. So I want to check those. Now again, this has to be 2x and x. So I want to check which one do I want to start with. I'm looking, I think this 3 and negative 5. Okay, so I'm going to come down here. I'm going to say 2x plus 3, x minus 5. If I distribute, 2x times x is a 2x squared. 2x times a negative 5 is negative 10x plus 3x minus 15. So then I get a negative 7x in the middle, which is what I want. Okay, so this is going to be 2x plus 3, x minus 5. And then look at how this final answer is written. The GCF is always written out front, and then I have my two groupings right next to it. Okay, I have one more of these. Feel free to pause. Do it on your own if you like. But I'm going to take out my greatest common factor. The biggest number that can divide 6, 28, and 32 is 2. So I'm going to divide all of these by a 2x. So my function is going to be 2x, that's the GCF, and then 6 divided by 2 is 3, x squared. 28 divided by 2 is 14, x. 32 divided by 2 is 16. So now I want to factor those brackets down into smaller chunks. So I'm going to say 3x and x. I'm going to list out my possibilities. So for 16, there's a lot for 16, I think. 1 and 16, 16 and 1. 2 and 8, 8 and 2. 4 and 4, and if I flip 4 and 4, it's the same. So I have 5 possibilities. That's not too bad. So which one do I want to start with is the question. I'm thinking I want to start with 8 and 2. So if I go down here and check, 3x plus 8, x plus 2, 3x times x is 3x squared, 3x times 2 is a 6x, 8 times x is an 8x, and 8 times 2 is a 16. So if I combine those terms in the middle, I do get my 14, so that worked out for me. So it would be 3x plus 8 and x plus 2. Do not forget to write the GCF out front at 2x. So I have this as my final answer. Okay. Now, let's review what we did in the last lesson. Okay. We discussed difference of squares. So we need to know all of these perfect squares. A lot of them you're probably familiar with. I think we all know the square root of 49 is 7. The square root of 25 is 5. You would know more of these probably than you think you do. All right. And I even put this little chart on each slide. But what I want to show you is I'm going to take the square root of this first term. Square root of 36x squared is just 6x. Square root of 49 is 7. So when I factor this, watch how easy this is. I'm going to make my groups. I'm going to say 6x plus 7 and 6x minus 7. Ladies and gentlemen, that is how you factor a difference of squares. That's it. That's all we need to do. Okay? So now if you take a look at this one up here, there's no number in front, but we all know there's a 1 there. The square root of 1 is 1. The square root of 64 is 8, right? You can check my table here to double check it, right? Square root of 1 is 1. Square root of 64 is 8. So I'm going to have my function, make my parentheses. I'm going to have a 1x plus 8 and a 1x minus 8. And ladies and gentlemen, that is my difference of squares. Same thing. If I take the square root of 81, that's a 9. Square root of 169, I'm going to look at my little table here. That's 13. So if I make my groups, I get a 9x plus 13 and a 9x minus 13. And that is my answer. Okay, so we really just have to identify the perfect squares. What is the perfect square of? Now, sometimes we have almost a very similar problem, but there are no perfect squares, right? 12 is not on my list down here. 75 is not on my list. So what I do want to do is I want to take out a greatest common factor. The biggest number that can divide 12 and 75 is 3. So I'm going to take a 3x out of each one of these. So now watch what happens. I'm going to have that 3x out front. 12 divided by 3 is 4. X cubed divided by x is x squared. Minus 75 divided by 3 is 25. And there wouldn't be any x's left. So now, take a look at what we have in those brackets. What's the square root of 4? Well, the square root of 4 is 2. I'm going to have 2x. What's the square root of 25? 5. So I'm going to have 2x plus 5, 2x minus 5, and ladies and gentlemen, that is completely factored. Okay, difference of squares. Square root of the first term plus and minus the square root of the last term. Okay? Same idea. Let's watch out for that greatest common factor. So the biggest term that can divide 7 and 28 is going to be a 7 and an x. So if I write this function, I'm going to take out that 7x. 7 divided by 7 is a 1, x squared. Minus 28 divided by 7 is a 4. If I break this up further, square root of 1 is 1. Square root of 4 is 2. So 1x plus 2 and 1x minus 2. Ladies and gentlemen, that would be factored completely. Okay? I broke it down into all its smallest pieces. All right? I think I got one more of these. So I'm going to take out the GCF, which in this case is 5. So my function is going to become 5x times the quantity, 1x squared minus 80 divided by 5 is 16. So now, if I do my difference of squares, if you notice, both of these, both of these are perfect squares. The square root of 1 is still 1. The square root of 16 is 4, so plus 4 minus 4. And ladies and gentlemen, there is my difference of squares. Okay? Now, here is the new piece for the lesson, and this is short, this is simple. Okay, stay with me. Now, we have to watch out for this when we have a quartic. Okay? So when we have a quartic. So if you look at my degree. My degree is degree 4. This is still a difference of squares. Okay, but we have to write it slightly different. So f of x equals, if I break this apart, this is going to become a 1x squared and a 1x squared. Now notice I didn't just use x and x. Why is it squared in those? Because if you break x to the 4th in half, you're going to have 2 x's in each spot. And then the square root of 16 is plus 4 and minus 4. But believe it or not, we are not done. Okay? This is a very special type of problem. The first group I can't do anything with because it's a plus. But the second grouping, I need to break down further because, again, it's a difference. Difference means subtraction. Okay? What's the square root of 1? Well, still 1. What's the square root of 4? Well, 2 plus 2 minus 2. So it's like a difference of squares inside a difference of squares. Okay? That's the idea. All right? So there's 2 steps. When you have a quartic, we're looking to do 2 steps. All right. So take a look. Same idea. F of x equals, if I break this apart, this would become a 1x squared plus 9 and a 1x squared minus 9. Now, we cannot break it further if it's addition. So we leave this first group the same. But the second grouping is subtraction, so we can break this down into 1x plus 3 and 1x minus 3, because 9 is still a perfect square. So ladies and gentlemen, this would be factored complete. Okay, that concludes our lesson today. So these two slides were the only addition. Everything else was kind of a review of everything that we've covered. So I need you guys to be able to factor a basic quadratic, pull out a GCF and factor that quadratic, difference of squares with the GCF, and then this special problem of a quartic. Okay, feel free to rewind, rewatch, email me if you have any questions. Thank you.